So I'm pleased to introduce Lavanya Ramakrishnan, whose career is sort of the opposite of mine. I was a postdoc I started at Lawrence Berkeley National Lab, and now I'm at Indiana. She got her degree at Indiana and is now at Lawrence Berkeley Lab. And she will talk about the results from, I think, the Magellan Project, which was a highly influential project, and actually Manish already mentioned it. And I will hand over to Lavanya to tell us about clouds for science. Thank you very much.
Thanks, Jeffrey. Should I just get started at this point?
Start.
Okay, so I'm going to get started. The last time I did one of these virtual summer school things, it was in North Carolina, and I did it in a big auditorium with no audience because we were not a participating site, but we didn't have students on our site. So that was a different experience. And I'm sitting here today in my office and trying to give you this talk, and I can't quite decide which one is easier or harder. Either way, I can't see you guys at this point. So I guess you can ask me questions, but feel free to drop me email if you have any other questions beyond what I talk about today. So Magellan was a DOE-funded project, and its mission was to determine the role of cloud computing can play in serving the needs of scientific applications. So DOE has a number of supercomputing centers and a number of science applications, and a number of these projects were interested in looking at cloud, so Magellan was that evaluation study. So the project ended last year, and it was a 2.5 year project, and we have a 150-page report out there if someone wants some bedtime reading. But in any case, I'm just going to summarize some of the key results here. Jeffrey suggested I should talk about a little bit about the performance results, and that's what my talk focus is mostly going to be on today, and sort of tease out some of the other aspects of cloud computing and the hype around cloud computing that we tried to figure out in terms of how applicable it was for scientific applications. So the first thing we did here was we said, okay, so everybody seems interested in cloud computing, and all our science users are telling us they want to use cloud computing. So let's try and figure out what they understand means what cloud computing is, and why is it that they want to use cloud computing? What part of cloud computing is the most attractive to them? So we took a bunch of sort of high-level things we knew about clouds then. This is back in 2009, and we put out a user survey, and we had a number of participants who are typically NERSC users. NERSC is the supercomputing center here at Lawrence Berkeley National Lab, and it has a wide range of application users. So we got a bunch of people reply back, and essentially what we learned was a large number of the scientists were looking at this as a way to get access to additional resources, right? So because we have this joke that we say here about science communities in contrast to sort of the more commercial web enterprise workloads, where if you give a scientist more resources, they'll figure out a way to use those additional resources because they have sort of an infinite thirst for computing cycles and data storage that they can use to solve other science problems. So the utilization on our systems are pretty high. They're 95% or more. And some of you might be familiar with some of the other supercomputing centers, including NCSA. And so we face a different kind of problem from the web enterprise workload, where most of cloud computing emerged from sort of we have these unused capacity, and how can we make use of that? So while this was our primary interest for our users, there were some subtle things that our users wanted which was not easily available to them in supercomputing environments, including the ability to share setup and software environments with their collaborators. They wanted specific versions of software to be available to them to do specific projects because they had large collaborations. They didn't all upgrade at the same time, whereas NERSC upgraded their software a little earlier in the cycle than some of the other collaborated partners. So they wanted to be able to control the software environment, and they said they wanted a way to sort of access these services, manage their data, and it sounded like cloud had all these promises, and they wanted to look at that. So we took this as our guiding principles as we worked through the project to determine what our priorities were and to determine what we should evaluate. So we had a bunch of research questions that sort of came about with discussion with DOE as well as our users that we sort of went out and addressed. It was a wide range of questions that we were trying to address, including sort of which of these open source cloud software stacks, and I know you've been listening about, hearing about all these in the last few days, are suitable and ready for DOE HPC science. Can DOE cybersecurity requirements be met within a cloud? What are the security challenges there? How usable are these cloud environments for scientific applications? How difficult is it for a scientist to come in and say, I want to use this cloud resource on this particular site, and how long does it take that scientist to ramp up and get started? The other thing that a lot of people are interested in is sort of the MapReduce Hadoop model, and this sort of came out from the cloud space. There's always a debate about whether that's cloud or not, but there was some interest in that, and people felt there was definitely some applications which could benefit from that new programming model, which may not strictly fall in the MPI space of that most of our users tend to use today on the NERSC resources. There's other things, including sort of how efficient is this, so how cost effective is this, and what is the ramifications for data-intensive computing. So we are, in most of the DOE facilities, producing data at a far rapid pace than we can easily process or analyze. It's both a hardware problem as well as a software problem, and so how much of the cloud space could address some of these questions. So I'm going to sort of mostly focus on the performance aspect and touch upon some of these other questions as I go along in my presentation today. And we did some work beyond Magellan in a data-intensive project here, and I included some of those results because they sort of tie in as a story into this as well.